Okay, so we're going to get into exponent loss. Okay, we have our first example here, and our first example, actually, what we're going to talk about is the many different rules. There are three major rules for this: multiplication rule, our division rule, and our power rules. Now, the reason there's not an adding and subtraction rule is because there really isn't one. You just equate what the numbers are and then add and subtract them after. But in terms of simplifying, if you're multiplying exponents with the same base, you can simplify it. If you're dividing exponents with the same base, you can simplify. And if you're multiplying an exponent, that's a power of a power, or double exponent, you can simplify it. Okay. I don't think we're going to get into radicals, but we can get into some negative stuff. And of course, zero exponent, any number to the power of 0 is equal to 1. Does not matter what the base is. Okay. So our first rule is multiplication rule. Let's bring that over. Right. Big rule here. Too much. There we go. Multiplication rule. What it says is when the bases are the same, okay, so x and x, we can simplify by writing that just that one base and adding the two exponents together. Okay. Let's just another highlighter. So we just add the two together. Okay. So in our very first example, we'll make some room here. Over here. Our base is the number 4. So in our answer, what's the base going to be? And we just add the two exponents together. So we get 2 plus 3. Our final answer will be what? 4 to the power of 5. Exactly. The same rule works with a. We have the same base a. So we have base a to the power of 2 plus 5. A is going to be what? Exactly. Simple. Okay. Our next major rule is a division rule. Okay. So bring that over. It's the same idea, only difference being, okay, is that our bases, again, they have to be the same. If the base isn't the same, we cannot do this. We can simplify it by writing one single base and then subtracting the two exponents that we have. So, same idea here. Our bases are the same. We have 2 and 2, so our base answer is going to be the number 2. And we subtract the top number from the bottom number always. So in this case, we subtract 5 minus 3 is going to give us what? An answer of 2. Easy. And the other one, base A, we take the top from the bottom, so 6 subtract 2 will give us an answer of done. Okay. And finally, an exponent of an exponent, or a power of a power, they call it. Power rules, same thing. Our base still stays the exact same, which is very key. And instead of adding or subtracting, we multiply the power of a power. So in this case, we take A and we multiply it by our B term. Okay. So our first one, we have a base 3, so our answer is going to be base 3, but instead we just take 2 multiplied by 3. And what will we get as an answer? Yeah. And again, A, we take 2 multiplied by 4. We'll get A to the... So it's a little disorganized, this page, but those are the basic rules. The key to doing this and solving this is to actually keep things in order and follow BEDMAS as we go through it. So we can get into some of those questions. Okay, so here we have a much more difficult example. I want us to simplify this. Okay? So what's important is kind of just remember your BEDMAS rules as we go through these things and what order we should solve questions. Okay? So according to BEDMAS, we should simplify what's inside brackets first if we're trying to simplify. Now I look inside. Are my exponents the same terms? They're not. There's really nothing I can do to simplify inside this bracket. Okay? So inside the bracket, everything's done. I can't do anything with the exponents. Can't add. I can't really divide yet. Nothing that. So brackets are done. Exponents. Well, I have an exponent outside of this question. And the exponent says to multiply the base, which is everything in the bracket, times itself 3 times. So in other words, if I were to rewrite that, that looks like this. 3x cubed divided by 4y squared. And just to give you a literal idea of this, okay, we're literally copying, oops, we're going to literally copy this bracket 3 times. So I take it and multiply it by itself once, and then I multiply it by itself another time. Okay, so that's what that's trying to say. That's trying to say 3x cubed times 3x cubed times 3x cubed over 4y squared times 4y squared times 4y squared. Now when I multiply fractions, I multiply the tops by each other, and I multiply the bottoms by each other. Okay. Those are just some fraction rules we have. So we'll just do a pair at a time. 3x cubed times 3x cubed, well, that's like saying 3 times 3, okay, which gives us 9, and x cubed times x cubed. Let's rewrite it again, so again that it's a little more simplified. I'll put this in one big bracket. It looks like this: 3x cubed times 3x cubed divided by 4y squared over 4y squared. And again, that's going to again be multiplied by the exact same thing, 3x cubed over 4y squared. Now I want you to think of this like our exponent rules. We multiply our coefficients, which is 3 times 3, we'll get 9. But this is x cubed times x cubed, or x to the power of 3, x to the power of 3. How do we simplify x to the power of 3 times x to the power of 3? What do we do with those exponents? We add them. So 3 times 3 is 9, and then x to the power of what? 6. And then on the bottom, how do we do it? 4 times 4 is 16, and y squared times y squared is y to the power of 4. Now, we're not done. We still have to multiply by 3x cubed over 4y squared. Same idea. We multiply our coefficients to start. So when we multiply the coefficients, 9 times 3, what will we get? 27. And we multiply exponents. X to the power of 6 times x to the power of 3 gives us, that's right, we just add the exponents. And then on the bottom, 16 times 4. Yes, that's right. 64. And then y power 4 times y squared. Y power 6. And that's it. That would be our answer. Now, I did in a lot of extra steps. You could probably do it a bit faster. You might be able to really just jump from here down to here. It's up to you, right? But I showed each of the steps as we went through. Okay, so example 5 here. This is a multiplication question. In fact, what this really says is this really says x squared times y to the power of 3. And this also says x to the power of negative 2 times y to the power of negative 6. Really, it's like saying this times this times this times this. We're multiplying 4 things. The rule of multiplication is we can multiply in any real order as long as we're multiplying everything together. So I can reorder this. That might get confusing. What I really want you to recognize is the only terms we can simplify are the base x's with each other, and we can multiply them, and the base y's with each other, because we can multiply them. So what's going to end up happening is, again, we're going to have base x to the power of 2, and when we're multiplying, times base x to the power of negative 2, and base y power of 3, y power of negative 6. Okay. When we go through this, actually we're going to get something a little special here. We keep the base the same, so subtract 2, right? We just subtract the exponents. And the other one we have y3, sorry, not subtract, we add the exponents, but in this case because it's a negative, it ends up looking like subtraction. Here, I'll write that in so that doesn't get too confusing. So it's 2 plus negative 2, and this is 3 plus negative 6. Okay. Well, 2 plus negative 2 gives me x to the power of 0. And y3 plus negative 6 gives me y to the power of negative 3. I can simplify more. What is x to the power of 0? Just 1. So it's 1 times y to the power of negative 3. I don't really need that one. But let's say they said they represented positive answer. Exponents. So if they want positive exponents, that draws me to this rule of the negative exponent. In fact, the base to a negative power can be represented as 1 over that same base to a positive power. Okay? Shoot, I didn't want to extend that page. There. Okay. So, in other words, what I do is that 1 is not important, so we have, well, it's not that it's not important, it's just, it's not relevant, it's not going to change our answers. I change this now. I put it 1 over y to the positive power of 3. And now we have positive exponents as answers in this question.